So let's go through some examples of rationalizing either the numerator or the denominator. It should be clear what you want to rationalize because the radical will be either in the numerator or the denominator. In example 1, we have 2 divided by the square root of x minus 1. Now obviously here, the denominator is what we want to rationalize. In the denominator, we have just a single square root of something minus something underneath, but it's not like there's something added outside of the square root that is not under the root. So when this is the case, it's often the simplest form that you can rationalize. So what we want to do is multiply simply by the square root of x minus 1 in the bottom and then also in the top. Now note that we can't just go squaring the top and the bottom. If we square the top and the bottom, we get something that's not the same. So, for example, if you have, I don't know, how about 3 over 4? If you go squaring the 3 up top and the 3 in the bottom, you're going to get 9 over 16. And if you put in your calculator 9 over 16, this is approximately 0.57 or 0.56, and 3 over 4 was 3 quarters or 0.75. So these are not the same. If you end up trying to square the top and the bottom, you will end up with something different. So what we have to do here is always multiply by a fancy version of 1. Okay, so when we do that in the top, we'll multiply across 2 times the square root of x minus 1. Nothing really to do there. And in the bottom, we have the square root of x minus 1 times itself. That's the same as squaring a square root. And so the square root is going to go away, and what we're left with is just x minus 1 to the first. Nothing more to do here. We've rationalized the denominator. It's in its simplest form, and so this is our answer. Now clearly here, the radical lives in the numerator. The plus 5 is actually outside of the numerator. So here is where we want to multiply by the fancy conjugate thing. Now, please feel free to look back at that chart if you want to, use that to help you conceptualize or organize the different things that we can see. But the idea is that when you have two parts and one of them is under a root and maybe the other one isn't, or maybe it's under a separate root, what we want to do is this conjugate business. So what we'll do is look in the numerator. We're going to find the conjugate of radical x plus 5, which will be radical x minus 5. We're going to multiply by that up in the numerator. If we do that, though, we also have to multiply by that in the denominator. Now we have to figure out what will be the result. So in the numerator, you can FOIL this out, or you can use the shortcut. That might be something I would suggest that you memorize from the previous table. The shortcut that I'm talking about is if you multiply a thing plus another thing times the first thing minus the other thing, this is a factorization of a difference of two squares. And so what you get is the square of each of the things with a minus between them. So what we'll get here, if we multiply this out, we're going to end up squaring the radical x. That's just going to give us x. We'll end up squaring the 5. That will give us 25. And then it's always, always, always a minus in between. Now in the denominator, we've got x times the square root of x minus 5. Whatever you're not rationalizing, you can often just leave it in its factored form. So what I mean by that is we can leave this as x times parentheses the square root of x minus 5. And there we've done our job. We have rationalized the numerator. There is no longer a root there. It did move to the denominator, but hey, it's the numerator's, not the numerator's problem anymore. So we are done with this. In example 3, we have x minus 36 over 6 minus the square root of x. Now here we see that the radical lives in the denominator, and it's part of a two-piece thing separated with a minus. So here we want to also do a conjugate thing where we're going to find the conjugate by looking at the denominator. Okay, so what we'll do is look at where the radical is and just change the sign in between the radical part and whatever else is there. So we're going to multiply in the denominator by 6 plus radical x. I'm going to stick parentheses everywhere. And if I do that in the denominator, then I have to also do it in the numerator. I'm going to put parentheses everywhere up top as well. Now remember that when you multiply conjugates together, what you get is the square of the first thing. 6 times 6 is 36, or 6 squared is 36. You get the square of the second part. The square root of x squared is just x. And then 100% of the time, there's a minus in between. So in the denominator there, we've got 36 minus x. Now, whatever you are not rationalizing, right? So here we are rationalizing the denominator. Whatever you're not rationalizing, in this case, the numerator, do not FOIL that out. Always, always, always leave factored. Whatever you are not rationalizing. So what I mean by that is just rewrite it with parentheses. Just rewrite that as parentheses x minus 36 times parentheses 6 plus the square root of x. Because sometimes we will be able to cancel something out with the numerator and the denominator. And if you go FOILing all this out or distributing it, you're undoing the product. And remember that multiply and divide undo each other. So we want this product here in case we can cancel. And what do you know? It looks like x minus 36 and 36 minus x. Those are really similar, except we've subtracted them in the opposite order. If only they were flipped around. We actually can just kind of flip something around if we factor out a negative sign. So we can rewrite the denominator as negative parentheses x minus 36. Now, if you need to see a little bit more about that, just factor out a negative 1. It's going to change the sign, negative 36 plus x, and I've just switched the order so that we can see that we can now cancel out the x minus 36. Now in the bottom, we will have a negative 1. And we can just write that as negative parentheses 6 plus the square root of x, or negative 6 minus the square root of x. And here is our rationalized expression. In example 4, we have 4 divided by the square root of x minus the square root of x minus 4. Now here we have two roots. They both live in the denominator. So what we're going to do here is rationalize the denominator. So we're looking here to decide what is the conjugate that we're going to multiply by. Well, we're just going to change this minus to a plus. This minus here has nothing to do with anything. We're just going to look at what is, under the root, what's under this root, and what's the sign between them, and that's the only one that we're going to change. So this is going to be the square root of x plus the square root of x minus 4. I'm just going to stick some parentheses there. Now, we did that on the bottom, so we've got to do that in the top. And put parentheses around there as well. Now, remember the shortcut. I always like to deal with the thing that we're rationalizing first. So that was in the denominator here. The shortcut for me is really fun. I think that it is satisfying to use. So the shortcut, remember, that I'm talking about is when you multiply a thing by its conjugate, you end up squaring the first thing. So the square root of x squared gives you x. Then you end up squaring the second thing, the square root of x minus 4 times the square root of x minus 4 just gives you x minus 4. And then there is always a minus in between. We just have to be extra careful here because we are subtracting all of x minus 4. And so if there's more than one piece to this, we have to make sure we've got parentheses around this entire thing. So I'm going to put those parentheses in blue. Now, the other part that you are not rationalizing, I would recommend that you leave it factored. So what I mean by that is don't go distributing the 4 into the parentheses. Just leave it as 4 parentheses radical x plus radical x minus 4. Now in the bottom, think about distributing this minus sign. Maybe you'll see that the x's are going to cancel out. So let's work on simplifying that. And again, I'm just going to leave the part we were not rationalizing fully factored. When we distribute the minus sign, we're going to get x minus x plus 4. Okay, here the x's will add up to 0. Up top, we have 4 times the square root of x plus the square root of x minus 4. And in the bottom, we're dividing that whole thing by 4. Here up top, the entire thing is multiplied by 4. Then we are dividing the entire thing by 4. So 4 divided by 4 gives us 1. So when we cancel those, we are just left with the square root of x plus the square root of x minus 4. Now we have rationalized the denominator here because remember that the denominator in an expression like this is really considered to all be over 1, and so we have done our job.